Hey everyone, and welcome to The Explainer. Today, we're unpacking the absolute secrets to mastering data structures and algorithms. But listen, we aren't just going to sit here and write code. No, we're going to learn how to truly drive a technical interview. Whether you're going for that first junior role or shooting for a senior engineering spot, how you communicate your problem-solving process, that's literally just as critical as the actual code you write.
Right, let's jump right in. The golden rule of any coding test is actually pretty simple. It's you who has to drive the interview. You know what you should never, ever do? Jump straight to the optimal solution. Seriously? Even if you know the exact answer right off the bat, just blurting it out kind of hurts your chances. Interviewers, well, they want to see how your brain works. They want to see how you handle constraints and how you talk about trade-offs. You really have to show your work. So here's our roadmap for today. We'll start with driving the interview, then tackle 3 classic problems: missing number, consecutive ones, and the loner, before wrapping up with how to absolutely nail your next interview.
All right, section 1, driving the coding interview.
Let's start with the meta skill every single candidate needs: presenting your thought process. To really impress an interviewer, you've got to deliberately walk them down a very specific 3-step path. First up, the brute force approach. Then, the better solution. And finally, the optimal solution. This framework, it's brilliant because it proves you understand how to manage your computational budget, specifically your time and space complexity. It shows them you can take a raw, totally unoptimized idea and refine it into an absolute engineering masterpiece. Let's see this in action. Section 2, Problem 1, the missing number.
Okay, so the prompt is an absolute classic. You need to find the single missing number in a sequence from 1 to n. Now, if you start with a brute force approach, searching the whole array for every single number, your time complexity just skyrockets to a massive O of n squared. That is way too slow. So you tell them, hey, I have a better solution: hashing. You create a hashed array to mark off which numbers actually appear. Boom, your time drops to O of 2n. But now your space complexity jumps to O of n because you had to create that extra array. We basically just traded time for memory. This is when the interviewer will usually ask, can you optimize the space back to O of 1 without sacrificing that fast time? Well, this is where you bring in a little math. You can hit that optimal O of n time with O of 1 space using the summation formula, n times n plus 1 divided by 2. It's super clever. You calculate the total expected sum of 1 to n, then just subtract the actual sum of your array. The difference? That's your missing number. But hold on, there's a big catch here. If n is a massive number, like 10 to the 5th power, that total sum is going to cause a huge integer overflow in standard data types. So how do we bypass that serious overflow risk? We introduce a mathematical magic trick called XOR, or exclusive OR. This is a bitwise operator. And honestly, it's practically a superpower in coding interviews. The main thing you got to remember here is that comparing identical numbers with XOR results in 0. Think about it visually. Identical numbers literally just cancel each other out to 0. 2 XOR 2, 0. 5 XOR 5, 0. At the same time, 0 changes absolutely nothing. 3 XOR 0 just remains 3. Once you understand that identical numbers annihilate each other, you've just unlocked this incredibly powerful, memory-efficient tool for finding missing data. And the best part? 0 risk of an integer overflow. So here's how we build our ultimate optimal solution. If we XOR all the numbers from 1 to n together, and then we XOR all the elements actually present in the given array, watch what happens. All those identical pairs, they annihilate each other. The 1s vanish, the 2s vanish, and so on. It leaves only our missing number to XOR with a 0. And just like that, time complexity is O of n, space is O of 1, and there is no integer overflow. It's brilliant, right? All right, moving on to section 3, problem 2, consecutive ones. Now, for this quick win problem, we're asked to find the maximum number of consecutive ones in an array. And hey, you don't always need a complex multi-stage progression. The logic for this one is incredibly straightforward. You just initialize a counter and a max variable at 0. Then you iterate through. Every single time you hit a 1, you bump up your counter and update your max. But if you hit a 0, well, the streak is broken and your counter drops right back down to 0. This perfectly illustrates that sometimes the simplest iteration is already the right answer. We had the optimal solution immediately, in a single pass. The time complexity is O of n, simply because we only look at each element once, and the space complexity, a beautifully clean O of 1, because we're literally only storing 2 simple integer variables. Okay, here we go. Section 4, Problem 3, the loner. We've finally reached the final boss of our explainer today.
Imagine you're given an array where every single number appears twice, except for one isolated loner. A linear brute force search? That's going to take O of n squared time. Ouch. A hash array is much faster, sure, but if the array has massive numbers, a simple hash array completely breaks down. A heavier map data structure fixes that, but then our time stretches to O of n log m, and our space budget totally balloons because we're forced to store half the elements as duplicate keys, plus that one loner. Now this right here, this is that precise moment in the interview where you take a breath. You look at those constraints you just laid out, you synthesize everything you've talked about so far, and you present the ultimate optimization. The big question is, how do we find this single element in O of n time without using any extra memory?
You guessed it, the XOR magic trick returns. Because the rules of the problem tell us that every other number appears exactly twice, we can unleash the XOR operator to do literally all the heavy lifting for us, and it won't take up a single byte of extra space.
Think about it. If we run a single loop and XOR every single element together, the magic just happens automatically. Those duplicate pairs of 1s and 2s, they simply annihilate each other into zeros. Poof, gone. The only thing left standing is our loner, in this case, the number 4. We absolutely nail that single pass O of n time complexity and that super strict O of 1 space constraint.
Finally, Section 5, nailing your next interview. Let's take a step back and distill the absolute biggest takeaways here. First, always show your foundational work. Remember, interviewers want to hire a logical thinker, not a walking answer key. Second, talk out loud about how you're managing your time and space budget. Show them you actually understand the cost of a hash map compared to a simple variable. And lastly, let the optimal solution naturally emerge from the flaws of your earlier brute force attempts. Mapping your logic out loud like that is hands down your greatest asset. So, I'm going to leave you with this final thought for your next technical screen. When you're sitting in that chair, staring down a completely blank text editor, just ask yourself, are you going to let the problem drive you, or are you going to drive the interview? The path from brute force to absolute brilliance is entirely in your hands. Thanks so much for joining me on this explainer today. Now get out there and code.